Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we have seen the closure property, commutative property and associative property of whole numbers. So in today's video, as the title suggested, we will be seeing the distributive property or the distributive law and also the operations that can be performed on this concept of distributivity. Along with this, we will also be seeing a few example problems and how you can use this concept and then apply while solving your problems. So without wasting any more time, let's jump right into the video. What is the meaning of distribute? Before we jump on to the topic, let us first understand the meaning of distribute. So what is the meaning of distribute in English? It means that distribute means to divide something or to give a part or a share of something. Right. So in here I have drawn a 4 by 5 table, as in for you have your graph paper, right? So assume that I cut a piece from your graph paper which has, these are called rows, 4 rows, and these are called columns. Okay, so this is a table, normal table, which has 4 rows and 5 columns. So what are the total number of cells? Assume this is one cell. So how many cells do we have? We have 4 into 5 cells. If you count also, we'll be having 4 into 5 cells in this table. So what is 4 into 5? That is nothing but 20. Right? So total number of cells or total number of squares in this table is 20. Okay, and in short we can just multiply number of rows into number of columns. Now I have divided this into 2 parts, 1, 2, right? So I have taken one table till here and I have taken another table till here. So I have divided this whole table into 2 parts. This is part 1 and this is part 2, and each part has how many cells? 10 cells, or in short we can write, because these are rows, these are columns, we can write 2 into 5. That is nothing but each part, this part has 10 cells and this part also has 10 cells. Since I have divided it, I am putting the sequence as is. So this part also has 10 cells, right? So 11 to 20, we have 10 cells. So what did you observe? We have taken this one whole unit and then we have divided this into 2 parts. That means we have distributed this into 2 parts such that this is part 1 and this is part 2, and each part has 10 cells within it. This is the underlying concept of distributive property. That means, how do we write this? We can write this all in the form of this. 4 into 5 is equal to 2 into 5 plus 2 into 5. Right? We get the answer as 20. Here 4 into 5 is equal to 2 into 5 plus 2 into 5. How can we write this? Can we write this as 5 into 4 is equal to 2 into 5 plus 2 into 5? Yes, because using, you know that multiplication is a commutative property, it holds true. So I have just reversed this. Now, can I write 4 as 5 into 2 plus 2? Yes. And then, once I write this, can I distribute this to 2 and 2? That means, we can definitely write that here we are multiplying one number to 2 or more addends that are joined by an operation. That means we are distributing the number that has multiplication symbol associated with it to two or more addends that have added. We are distributing the multiplication over addition. This is the distributive property of multiplication over addition. That means we will be writing this as 5 into 2, because first we'll be multiplying 5 into 2 and then we have to retain this symbol plus, and then we will be writing this again as 5 into 2. First the first number and followed by the next number joined by the operand inside the parenthesis. Okay, so can we say that this result 5 into 2 plus 2 is nothing but 5 into 4, that is 20, is equal to 5 into 2, 10 plus 10? Yes, because 20 is equal to 10 plus 10. That means, in short, we can conclude that the number that we get after distributing, or the total that we get after distributing the multiplication over addition, is equal to the one that we get before or without distributing. That means this result is equal to this result. This is called the distributivity of multiplication over addition. Okay. So you will be having a question, why do we have to do such a big method? Rather, we can directly substitute, as in directly we can add the result as 5 into 2 plus 2. We can just add this as 4 and we can write the result as 20. Why can't you do this? Why do you have to follow this entire process? The reason being, here it is easy. Here we can simplify and we can add. There are two reasons that I can think of to explain this to you. One is, whenever we are trying to multiply big numbers such as 25, you can do 35 into 20 plus 5, and then you can easily multiply 35 by 20 plus first and then 35 by 5, and then we can add. That means this concept of distributivity will simplify your method of multiplication. We will see these problems after discussing few more topics, but this is how I could easily think of a way to simplify your multiplication, and this is very important for you to perform while you are writing a competitive exam or any Olympiad. Speed matters. So if you use the concept of distributivity, you can multiply two numbers with utmost speed and efficiency. Okay, this is one use. Second use is, not everything is in numeric form. That means we also have algebra where we have variables. So what happens is, sometimes we will be getting this a into b plus c. Okay. So what happens is, or else you can say 10 into b plus c. What happens is, we can't add b and c directly here. We are multiplying a number, and whenever we have variables inside the brackets, we cannot add these variables, right? So rather what we'll do is, in order to simplify this, we will be applying distributive property and we'll be writing like this, 10 into b and 10 into c. So this is how we use distributive property. Especially the importance of this will be proved and shown to you during our discussion on algebra. Okay, so that is the reason distributivity of multiplication over addition and over subtraction also it's possible. Let's get into that, but this concept is very important. Now let's see the actual definition of distributive law. It is nothing but whatever we have discussed before. If A, B, C are three whole numbers, here we are dealing with whole numbers, so we will write whole numbers. Then A into B plus C is equal to A into B plus A into C, or B plus C into A is equal to B into A plus C into A. Do not get confused by the variables that are written here. Here these variables are nothing but whole numbers. That is, A, B, C can take any whole number values such that whenever we multiply one whole number with a unit, as in with two addends added, then we will distribute this multiplication over this addition. That means we will multiply A into B first, and then we will multiply A into C second, and then we will add them, as in whatever sign is here we will add them. Here it is nothing but the commutative, because order doesn't matter for multiplication. What we have done here is we have added and then we multiplied towards the end. So here also it states that this will be multiplied by this first, and then we will add, and then we will again multiply this by this. This is first, second and third. So this is nothing but the concept of distributivity. Please note that A into B plus C is same as this. That means whenever we have a number like this, this means 3 is multiplied by 5 plus 4. Sometimes the multiplication symbol will be written, sometimes it's not written. In most cases, as you grow and study higher studies or in 8th, 9th, any class, they will not write multiplication symbol before. It should be implied that whenever we have direct brackets written after 3 or after any number or after a variable, in this matter A, then that means it is multiplication, and then immediately we can distribute this as AB plus AC. That means this is dot. Here A into B and A into C. This is represented by a dot. Okay. So this is the concept of distributive law. Also please note that these numbers in the brackets, they can be more than 2, as in, let's see one example. Here we can say 2 into 3 plus 4 plus 5 plus 6 is equal to 2 into 3 plus 2 into 4 plus 2 into 5 plus 2 into 6. That means 2 into what is 3 plus 4? 7 plus 5, 12 plus 6, 18 is equal to 2 into 3 is 6, 2 into 4 is 8, 2 into 5 is 10, 2 into 6 is 12. So it will be nothing but 36 is equal to 14 plus 12 plus 10, which is equal to 36. It is proved. The result is the same even though we distribute this multiplication over addition. So I've just written this to show you that these can be more than 2 addends inside the parenthesis. Okay, so this is the distributive law. Distributive property of multiplication over subtraction. So distributive property of multiplication can not only be applicable for addition, we can also do the similar set of operations on subtraction. For example, if A, B, C are 3 whole numbers and B is greater than C, then A into B minus C is equal to A into B minus A into C. That is, here instead of plus we have minus, and we will distribute this multiplication over the addends that has minus in between. This multiplication over subtraction distribution is very easy and helpful for us to apply in any complicated problems, especially in algebraic expressions. So this can also be written as B minus C into A is the commutative, is nothing but B into A minus C into A, and Please note that here A into B is greater than A into C, because else we get negative answer. So this is the distributive property of multiplication over subtraction for whole numbers. Let's take an example. Let's take 20 into 20. Okay, I am just taking this easy to simplify, but let's see how this is applicable. I will write 20 as 22 minus 2, right? So we will get, by applying distributive property, we will get 20 into 22 minus 20 into 2. So we know that this is 20 into 20 is nothing but 22 into 20 is minus 440, and this is 40. So 20 into 20 is 400 is equal to 440 minus 440 is 400. Okay, so this is the distributive property of multiplication over subtraction. Now let's see a few exercise problems of distributive property and the application. Now let's see how to solve these problems. So I have written 5 problems on the board. So let's tackle one problem at a time. So the first problem is 12 into 35. Remember, for these we need to use distributive property. So 12 into 35. How can you write 35? You can write 35 as 30 plus 5, right? So using distributive property, this is A, this is B, and this is C. So we know that A into B plus C is equal to A into B plus A into C. So 12 into 30 plus 5 is nothing but 12 into 30 plus 12 into 5. Am I right? I have just distributed this first and then this and then added. So it is nothing but 360 plus 12 3s are 36 into 10 360 plus 60. So the answer is 420. See, without multiplying 12 into 35 directly, you can simply do distributive property and then you can multiply it very easily, because you know 12 3s is 36 and this 360 and 12 5s are 60. So we get the answer very easily, right? Now let's see the second problem. Simplify 126 into 55 plus 126 into 45. Here, what they have done is they have given you this. So can we not easily simplify this by taking 126 as common? Here, common means A, because A is common here, as in this number 12 in this previous example is common. Common as in this is applicable for this is also applicable for this, right? So what is common here, as in what is the same number here repeated twice? 126. So we will take 126 into, can we add 55 in this form, plus then 45. So this is in the form of A into B plus C, or you can also write this as A into B plus C, right? So this can be written as, what is 55 plus 45? 100. So that is the reason we are taking that as common, because we know for a fact that the moment we see 55 and 45, you should remember that this sums to 100. So into 100. So this is nothing but 12600. Okay. So this is the second problem. So first problem answer is 420. Second problem answer is 12600. Let's see the third problem. What is the third problem? Third problem is 4795 into 995 plus 4795. Right. You know that here this is common, right? But you are wondering, there is nothing that is mentioned after this for us to add this and this. This is nothing but this is in the form of A into B plus A into C, right? We don't know what is C here. So what do you know? If we multiply a number by 1, the answer is the same number, as in 1 will not change the identity of that number. We will see additive and multiplicative identity in the next video. But for now, we know that when we multiply 1 to any number, for example 300 into 1 is also 300 only. If we multiply 1, we will not change the identity, the value of that number. So, in this way, can we not say that 4795 into 1 is nothing but 4795? Yes, in one table. So, here C is nothing but into 1 based on this concept. So, what we will do now is, we can write this as 4795 into 999 plus 4795 into 1. So, here take 4795 as common and then you write 991 plus 1. This is nothing but 4795 into 999 plus 1 is 1000. So, it is nothing but 4795000. Okay. See, how did we solve this? All these are, you need to identify that these are in the form of the distributive property. If they are distributed, you can just combine and write the left hand side of that property, right? So, this is the answer. So, it is 4795, 1, 2, 3. What problem is? 887 into 10 into 461 minus 361 into 8870. Here we have minus. And this is nothing but distributivity of multiplication over subtraction. So, here you know this number, there is no common number here. First we need to get the common number. First one is identify what is common. Common number. So, here the common number is 887. There is no common number. Let's try to multiply 887 into 10. It is nothing but, what is 887 into 10? Is nothing but it is 8870. So, can we write this as 8870 into 461 minus 361 into 8870? Yes. So, here we can see that 8870 is common. So, it will be 8870 into 461 minus 361. Note, this is greater than this. In this case, B is greater than C. So, 8870 into 100. Think about 887000 is the answer. Okay. You need to identify the common number so that it will be easy for you to simplify. Okay. This 5217 into 325. This is a big one. If you see, this is like very big. So, how do we simplify this? How do we break it down? Do you think that if you multiply a 4-digit and 3-digit number, you will get the answer quickly than breaking it down? It's again dependent on your speed. But if I were you, I will break this big number down into distributive property so that into small chunks so that I can easily multiply. Let's see how that's done. Let's say 325 is the common number here. How do you write 5000? We write this 5200, 10 and 7. Can we write this like this? Yeah, so that is nothing but, if you take this and add, it's nothing but 5217. Why are we simplifying this like this? So that we'll get zeros here and it's easy to multiply 325 into 5 and then add 3 zeros than multiplying the entire 4 and 3-digit number. So we'll get, after multiplication, after distributive property, we'll get this as 325 into 5000 plus 325 into 200 plus 325 into 10 plus 325 into 7. So this is nothing but, let's try to get the answer of this. What is this? 325 into 5. So it is 25, it is 12 and this is 16. So it is nothing but 1625 into 3 zeros. 1, 2, 3. Okay. Plus, what is 325 twos are? 650. So 650 into 2 zeros. So it will be this plus, what is this? 3250 plus, what is 325 into 7? See, you just need to do 325 multiplication. 35, 17, 22. It is 2275. If you add this, you will get the answer. So it's nothing but 5, 12, that is 4, 5, 10, 15, 8, 9, 6, 1. So the answer is 1695525. This is how you apply distributivity on various problems or various multiplications just to simplify your calculation. I hope you understood the concept so far and enjoyed the video. So if you like my video, I request you to please like, share and subscribe to my channel if you're new, and ring the bell notification down below so that you will never miss an update from me. So I hope you understood the concept very clearly, and if you have any questions, please feel free to reach out to me over my email that is located in the description box. Until then, I hope you have a safe day and wonderful week ahead. The puzzle of the day and the previous puzzle suggestion will be as follows. Bye.